The topic for the day today is problem solving with equations. And we're going to do this by setting up tables to help us organize information. So let's take a look at our first problem for today. Tom and Tina set out on their bikes at noon and travel toward each other. So presumably they're starting in two separate places. They are meeting at 2:30 p.m. Tom's speed is 4 miles an hour faster than Tina's speed, and their starting points are 50 miles apart. All right, so how fast are Tom and Tina each riding? There's two questions here. How fast is Tina going and how fast is Tom going? We know neither of those things. It's two things we don't know. We're going to use what we do know to help us get to the bottom of this. So first of all, whenever you start a story problem, you've got to have an idea of what kind of formula you're going to use. This is a great distance formula problem. Distance equals rate times time. All right? That's the formula we're going to start with. Now what we want to do in our table is fill in everything we know. So first of all, we have to figure out how long was Tina riding and how long was Tom riding. But that's given to us in the problem. They both started at noon. They both met up at 2:30. That's 2.5 hours. All right? So both of them rode for 2.5 hours. So we're going to fill that in. Now, their speed, we need that. We don't know that. Here's what we're going to do. Take Tina, make hers X. Here's what we know about Tom. Tom's speed is 4 miles an hour faster. So her speed is whatever this is plus 4.
4 plus X.
Beautiful. Now, the way that we get the distance is rate times time. So we're going to take this times this and write it here. See where I'm going with this? Now, here's the last piece of information we know. Their starting points are 50 miles apart. So however much they each rode, and it's not 25 and 25, because remember, he rode faster, so he's going to cover more distance than she is. It's a different split. But we know that together it adds up to 50. We just don't know how it splits up. Okay? So together, it adds up to 50. Now, we actually don't care how it splits up because that's not what we're being asked. So, we don't know that, but we don't care.
So we're done?
No. We have to figure out what X is. Because we were asked how fast are Tom and Tina each riding. So, here's our equation. This distance, together with this distance, totals 50 miles. That's our equation. So, we have 2.5 times x plus 4 plus 2.5x equals 50. Now we have an equation to solve. The coolest thing about these lovely story problems is you can use decimals if you like. Don't care, okay? So, let me grab my calculator. I have 2.5 times x when I distribute. And 2.5 times 4 is 10. Plus 2.5x equals 50. My next step, I'm just using my equation solving knowledge now. Combine my like terms. 2.5x and 2.5x is 5x. Alright, my next step, subtract 10 from both sides. I'm going to write that really tiny here. And I got to go over to the side. So I've got 5x equals 40. Divide both sides by 5. And we have x equals 8. Go back to your problem. That's this. Now whenever you're answering a story problem, use units. So here's what this is. Tina is going 8 miles per hour. Tom is whatever Tina is plus 4. So 8 plus 4 is 12. This is 12 miles per hour. Fair enough?
Yeah.
You're going to do some problems like this. Let's do a different kind. Okay. A geometry type problem. We have a quadrilateral. Remember, 4 sides. Not necessarily a rectangle. Not necessarily a square. Not necessarily a trapezoid or any other shape we know. It's just a shape with 4 sides. Alright? In quadrilateral ABCD, the measure of angle A, we're going to have 4 angles, alright, exceeds the measure of angle B by 20 degrees. Here's how we can do this. We've got to figure out what all these angle measures are. What is the total of all the angle measures in a quadrilateral? That's a geometry fact. Does anyone remember what that is? 360. So the total has to be 360 degrees. Now, if A exceeds the measure of B by 20 degrees, make B X. And if A exceeds that by 20, A is X plus 20. Okay. Also, the measure of angle D is twice the measure of B. All right, D is twice as big as B. So D would be 2x. And it says D is half the measure of C. Now this is a little bit of logic you got to work around. If D is half of C, which one is bigger, D or C? If D, just listen, if D is half the size of C. C is bigger, so C is 4x. Now D is half the size of C. All right, so you just got to read the words and you got to figure everything out. Now, here's the problem. 1, 2, 3, 4 things added together equal 360. So I've got x plus 20 plus x plus 4x plus 2x equals 360. Combine like terms, 2 and 4, 6, 7, 8 x's. So I've got 8x plus 20 equals 360. Subtract 20 from both sides. And I've got 8x equals 340. Divide both sides by 8. And I've got x equals, calculator, 340 divided by 8. Oh, decimal. 42.5. All right, so go back to your problem here. X is right here. This one must be 42.5 degrees. X plus 20, so add 20 to it. This one is 62.5 degrees. 4 times x. So take my 42.5, multiply it by 4, and I get 170 degrees. Then I've got 2x. So I'm going to take 42.5 times 2, and I get 85. 85 degrees. Now, I can double check myself by adding up these 4 numbers in red and making sure that they equal 360, and I know they do because I've been doing this problem for a lot of years. All right? Go to C. Okay, adults tickets for the museum cost $1.50 more than a child's ticket. One day, 200 adult tickets and 160 children's tickets were sold. Total sales for the day were $1,290. What is the cost of each adult ticket? So here's what we're going to use. We're using a formula where we take the price of something times the quantity that we have And that'll give us the total sales. All right? And we have two categories, adult ticket and child ticket. So first of all, the quantity is the number of tickets. The price is the cost per ticket. All right, so the quantity of tickets is here. There were 200 adult and 160 children's tickets. We don't know the price of either one of them. All right, so what we're going to do is it says the adults tickets is $1.50 more than children's tickets. So let's make the child ticket X, and the adult is X plus $1.50. Remember, we can use this formula to get the sales. So I have 200 times $1.50 plus X. Sorry, I switched them by accident, doesn't matter. And 160X. Now I know that the total of these two categories is $12.90 because I was given that in the problem. So 1,290 goes here. My equation that I'm going to solve is this amount of sales plus this amount of sales. The adult sales and the child sales equals $12.90. So let's go over here and we'll write the equation. So I've got 200 times $1.50 plus X plus 160X equals 1290. That's my equation. Go ahead and distribute. So 200 times $1.50 is 300. So I've got 300 plus 200X when I distribute plus 160X equals 1,290. Combine your like terms. So add the 200X and the 160X. So I've got 300 plus 360X equals 1290. We now have an easy problem to solve. Subtract the 300. And I've got 360X equals 990. Divide both sides by 360. All right. 2.75. Well, that makes sense. Go back up to your question here. X is 2.75. So right here, this is $2.75 a ticket. Remember, the adult ticket is $1.50 more than that. So add $1.50 to that, and we get $4.25. So $4.25. This was our question. Therefore, that is our answer.
Those are some cheap tickets. What? For a museum?
For a museum? Yeah.
Yeah. We did it.